Good evening. Good evening. I hope all you are doing well today. Yeah, cold outside, but thank you for coming. And I would like to also thank DevClub and EPAM for giving us opportunity to speak. Thank you. Today's talk, we are going to cover the site reliability engineering and practical implementation. I will cover the real story, how it was implemented in one of the companies. So, based on our experience, I will try to cover this. My name is Akbar, and I'm a senior solution architect at Ness. At Ness, as I said, full lifecycle digital transformation service. So, we have 11 innovation hubs across the globe, and we have more than 305K employees. Our headquarters is in Teaneck, New Jersey. You may know, maybe, and they also have office here in beautiful Riga. Our main strategic partners and our tech stack, it's to Ness is by itself, it's a cloud agnostic company, so we are focusing on the digital transformation. So it's obvious that we have a public cloud providers such as AWS, Microsoft Azure, and GCP as well. So we are a prime consultant partner in the AWS, so we have a 300 certified specialists in many different areas, so data mobility, cloud migrations, etc. As well, we are a big partner of the Confluent. It's a primary partner that are focusing on the Kafka, focusing on the big data and data streaming. There's Kinesis, etc. So also it's mostly seen in the financial areas and the brokers. So as well, we are using our own tech stack. We are a digitalization company that is meant to transform your solution, for example, on-premise solution to a more cloud. We suggest we find the perfect solution for you using the best practices. Also, we have a programming stacks, as you can see, many programming stacks. And also, as I mentioned before, we are focusing on the many different areas such as financial sectors, green engineering, energy, data migration, and so on. So, everyone, welcome to visit our webpage, ness.com. Okay, in today's agenda, I will try to cover 4 main topics. First is reliability. I will highlight most important things about reliability that maybe some of us should know. I will cover the story, as I said, the real story, how we faced the problem, what kind of a solution we found, how we change our mindset during the process, and the transformation, actual transformation. From the story of the company, how they transformed and build up the new team, build up the new targets and strategy. Finally, I will share the result. So, let's move on. Reliability. Anyone knows what reliability means? Maybe? Some of? A few sentences it would be now.
Buzzword.
Anyone else? Okay. We can understand reliability as the ability to achieve a goals without any failure. So, if you have a less failure, you are reliable. But that's not enough reliability. There's the core pillars of the reliability itself. Reliability is one of the domains in the trust. What is trust itself? It's trust. We can name it a relationship trust. Whenever we introduce ourselves to someone or getting the interviews, and trust works like that. So you start in your trust, and the reliability is one of the core pillars of trust. How we build the trust? Anyone knows?
Good work. Delivering expected results.
Brand promise. Brand promise is your trust. So, it's not a secret that every business, whenever they start, either it is a startup or a company with a big investment, they need to make a name for themselves in the market. You can name whatever a company, let's say a brand. What's a brand? Okay, Microsoft, let's take a Microsoft. They take a years to build their trust, so we can trust. Even the Microsoft can get updates, or maybe for example hours, but we trust. Yes, we are using them. We trust. How they build their trust? First of all, they bring a promise. Every business starts with bringing a promise, such as our product will make your life easier. Our product will meet your expectations. For example, make your life easier, make some things automated. So that's how we bring a promise. So the brand exists in the most elementary form to provide the solution to a problem that exists in the marketplace. Then we start actually building a trust. As I said, when you define and when you find the customers, you just promising it, but you didn't show it in the real world, how it should work. Then you're building a trust by demonstrating, going to events like this, for example, showing a demonstration how your product is working, application how it's working. And the thing is, in the trust, it's very, very, how to say, soft. I think it will be the right description, because gaining someone's trust, could be very hard, you know, very hard, because you need to prove that and that and that and that. Many things you need to prove, but losing the trust, that's it, you're done. No one will come up to you again. No one will trust you, and you will be labeled as an unreliable, untrustable company. Who will work with you again? I think no one. Unless you are Microsoft, they can. Or Apple, okay, or Apple, even that. They built already their trust. They can use their trust how they want. But they never, ever playing with their trust. Like, okay, we built this solution, let's rip it up. Let's leave it. No, they are continuously evolving it, and we have, for example, Microsoft 11 today, and I think most of it. Well, Vista. Well, yes, it is a good example, Vista. How many users are just cursed at the Vista, right? It was after XP, the big XP, Windows XP. I think some of the companies still using XP because it's reliable. Still reliable, yes, it's auto support, but it's still reliable, you know. And even, for example, I had an experience playing, recently installing XP because some of the games played only in XP. I would like to have some nostalgia playing those games. New operating system doesn't support it. So you launch your VMware, launch your XP, and work, boom. So, but reliability consists in two ways. Let's say we have a product reliability. What's the product reliability? It's basically your software. It's basically your manufactured product. It could be a car, it could be a software, it could be everything you need, everything you see, tables, floors, etc. So, defines the probability that product, system, or service will perform. What does it mean will perform? So again, we are going back to a promising. We are promising that product, system, or service will perform, but after comes the magic of reliability. Will operate in defined environment without failure. That's how product reliability works. But the product reliability, it's different in terms of software, and it's different in terms of, let's say, manufactured product. Let's say in the software, you don't pretty much care about what's happening in the backend. For example, testers doing something for you, you don't see it. Programmers are testing new features, you don't see it. You only see the changelog, and I'm pretty much sure not that much people are reading the changelog of the application of the product. So it's working, they have new features, and yes, good. But if you say about the manufactured reliability, let's say a car. I think it will be the good question if, do you pick a car, preference a car, by its reliability? No, it will not be the obvious answer. You pick your car by your, let's say, quality, for example. You would like to bring up a latest Mercedes, for example. rather than old Mercedes, which is reliable, for example. It's a preference. For example, in the way of the manufactured devices or equipment is working, it's a work of a preference. But after a time, you will start to realize about and understand about the reliability. Spending a lot of money in the service centers. Oh my God, you can say, I bought this car and half of months this car is laying in this service center. This is reliable? No. Quality? That's a different topic, I think. And with the software, it's working in a different way. Because, as I said before, you just use the software at the end user. You don't pay attention how it was passed through stress test. You don't think about how was it written, in which language is it written. It is capable to maintain all things. You don't care about it. You care about only its functionality. And pretty much that's it for you at the end user. It's a completely different thing, but lots of comment. They are both should be reliable at the end. And the product reliability is the one of the, let's say, bottom line of business reliability. In the business, you may have 1,000 of products. And the combination of these reliable products make your business reliable. Let's say you have a 99 applications which is completely not reliable. Enormous outages, always, but one product is reliable. Does it mean your business is reliable? Of course not. Of course not. Only one product existing in your marketplace and 99 others not working. It's not the means that business is reliable.
Depends on the money, how much this product will
One
give.
application generates revenue for whole business, so it's not a problem.
But the question is, why, if they created one application, why they created 99 applications? Can you answer that?
Proof of concept.
Proof of concept, 99 applications to proof on, and they deployed in the market. That's a new. Okay, okay, could be. I don't know. Could be. Okay, so as you understand, the product reliability, it's kind of a pieces to build the reliable business. So as I said previously, the trust is the fundamental part of every business reliability. Customer satisfaction, efficiency. Let's forget about efficiency. We're talking about reliability and customer satisfaction at the end. If your company is trustable, your customer is satisfied. Forget about the Vista.
That means the product is efficient.
That means the product is efficient. Yes, good factor. And success factors. So, that's kind of a more management stuff. Let's talk about more interesting things. Our story. How we successfully implemented site reliability engineering. When I will say the successful, it will be a little bit hypocritical, because it was a big amount of time, big amount of nerve and things spent to bring up a success. So, how it started? A story. A company was initially a construction company. They was not intent to build their product, build a software product. They was also only focused on the construction part. They were using their own systems. They had a big facility of IT facility engineers, but they never were focused on IT field. So, and then they created a product. Which is helped to carry land surveying, because there wasn't, at that time in 2012, there wasn't such a product in the market. So the company invested to build their own product. So company started actively using this product, and it was very satisfied with it. There was never be intended to publish in marketplace or itself. So there wasn't any issues. There was a couple of guys who maintained the product, couple of developers who developed the product. But as the company is evolving, they start to call it constructors. Constructor, it's who brings their equipment, who brings their human resources, talents, etc. So they bring contractors and they ask them to use their product, to have a common, consistent billing system. Because why? Because the constructors have their own system of calculation, and when they start to merge, there was the incompatibility, because one of them using SQL-based databases, one of them was using non-SQL-based databases. So just the k-value, but one of them was using just a relational database, and it wasn't compatible. And for the engineers to every day transfer this data was really a big challenge. That's why they asked to bring up a common, consistent billing system. Problem starts obviously because they already connected 10,000 devices, which was not meant to be used in the for this product. The infrastructure failure. Everything started to fail. The application itself was not initially multiprocessor, multi-tracking. So this kind of a failures start to appear, and everything's collapsed. Management was just very angry, let's say. Management was very angry, and they didn't know what to do next. So the problem, for example, if you can see the Richter scale, how they used it before the constructors joined and how they used after. This is the scale of the outages. So you can see there is a couple of outages, maybe per month or per quarter. But after the tons of devices joined, API expanded, you can see that's almost 8.8. By Richter scale, it means it can, if you can convert it to an earthquake, it could damage, I think, a tsunami center completely, can destroy the city. So, as you can see, the product was actively developing at that time. So the major jump from the 6 point, they thought about it. Our product, our software is not capable to handle, but doesn't want the issue. They invest the money in the infrastructure, in the hardware. They didn't help. So at the end, they didn't know what to do and came up with a solution. Onboarding the site reliability engineering practice. Site reliability engineering, it's founded by Trainer Gloss in 2003 at Google. So it's an actively growing process at that time. But the company who was focused on constructions, do they care about such things like site reliability? I don't think so. Let's be honest. It's not an IT-related company, even though they have a big amount of budget for IT. So the solution found in the SRE. But to implement SRE, they thought, okay, we will just hire the people, and then boom, we will label them as SRE. Eventually, it didn't work because till 2012, they understand that they work for machines, they work for infrastructure, they work for application. And it was a complete wrong mindset. But after 2014, they start to think, why we should work for them? We bought them, but we work for them. There's no reason to do it. Let's convert it. So they think about machines work for us. And the collapse again starts here. Because business itself wasn't not ready for this kind of changes. Came up and with the hiring process. Hiring process was not capable to do such things. So they involved third-party companies to help hiring a specialist in the SRE, in the different aspects, in the development, for example. Team talents. Adaptation was completely disaster because management was not adapted to that kind of a change. So this kind of a process involved. Transformation. Now begins the transformation. How we create the master plan? That will be actual implementation of SRE. As I said before, the business wasn't ready. The business wasn't ready, and they start to think about let's change from the beginning. Let's start from the beginning. So we need to optimize our business so it can optimize the product. We built a design. So by design I mean design of how things should work. For example, how the talent acquisition team should work, how the investors should work, how the main business should work, how the product manager should work. So they starting to design. After that, the modeling comes. Modeling was pretty much easy. Once you have designed everything, you just combine them in one piece. It was very easy modeling. Monitoring was eventually exist already because after so much failures, you don't need for monitoring. It was obvious. Your product is not capable to manage this kind of connections. Execution. So they skip the monitoring, start from execution. And this was the plan. This was the plan. They had a rapid changing plan because they invested a lot in the product. They start to invest in the people finally. Not in the hardware, but in the people. So they start to build a cross-functional team. After they fixed everything in the business side, as I said before, the human resource, the talent acquisition, the motivations, their organizational processes. So business agreement, is they established a business agreement, they define the SLA, SLO, SLI. They start to understand what does it mean. Even though the company is not start to sell this product, the product was only for themselves, even though the contractors were using them, because they didn't want to spend on extra development group who is transferring the data. They already had a product. They need to just define this way. Eventually, then also start to think of a center of excellence and cloud foundation, because keeping all of this kind of stuff in the local on-premise, I wasn't any kind of a good choice, because there's a lot of factors keeping up your infrastructure on-prem. You also should be reliable, you know. Also, you should also maintain it. So it's really big cost. So they think about the cloud foundation and cloud migration. Start to define the streams. I'll talk about the streams later, but epics. Basically, you can think about the Jira epics. So they write the high-level epics and start to think about the release management, continuous operations like we know today, like CI/CD, CM. So they start to think about continuous operation. Toolset and framework. So finally, they start to think about the toolset and frameworks rather than think about the hardware, then agreements. So then process of the feedback and long terms, it's just your result, how it should work. But I would like to highlight one more thing, it's advocating process. It's very important because you can create the process, but if you don't advocate, it will just die. You need to continuously advocate the process. For example, change management process. You need to actively push your team, push your members that they need to use the change management process. Otherwise, why you need the change management? So this kind of things will start to build the company at the target. Of course, the SLA, and beautiful words. Basically, they start to think about the smallest possible, for example, .9. And their budget was pretty much capable, pretty much acceptable, almost 9 hours per year. They think about that, we can manage that. So, and they also use the Google recommendation. The more reliable system, the more expensive it costs. And they also think about the cloud, but you need to understand, if you have a reliable product and you define your SLI in terms of in traditional way, and you try to move the cloud, you hit another SLA of the cloud, because they're also providing it. You can even put the whole nines, but if, for example, you move to Alibaba Cloud, let's say, and they give you only the 99, you cannot exceed it. Obviously, you cannot exceed it. So it was, obviously, they choose the best possible, according to their error budget, according to their capability, and start to move on. And one of the biggest challenges during the process is the build-up, team build-up. they tried to first, most traditional structure, flat. Because everyone was in the same page, aligned goals, higher productivity, organization clarity. It didn't work. It didn't work because of the decision conflicts. You need to understand that the engineering team was really fresh. They didn't kind of get familiar with each other. They didn't work for 5 or 6 years together. So there is a collaboration issue with them. You start to work with one guy and you don't know about him anything. So you kind of start to think, what is he doing at the end? Why I'm doing this and why he is not doing that? And we are talking about the root cause of the problem when you're building a new fresh team. We're not talking about the existing solution. So eventual challenges are faced. Required more seniority. There was everyone on the same page. Who's the senior? They can't ask the business unit, please take a decision, should we buy this monitoring tool or not? He will say, really, Tom, I don't know, do whatever you need. And 6 people say, I want Zabbix, I want Nagios, and etc., etc., etc. Different mindset, different toolset, no common decision. So they moved to the next one. Eventually they found the problem in hierarchical system because no one can take a decision. Here you can say that, yes, hierarchical decisions for us. It's clear career path, straightforward reporting structure, and as well we can ask who is responsible for that particular decisions or particular finance sectors, for example, buying this tool set or not. But again, it didn't work eventually. Why it didn't work? Because of the decision dependency, bring up the bureaucracy. It start to mailing, we need to this tool, we need that tool. They start to build a combination list, why we use this tool, this tool, this tool. It didn't work. Because we expect to have subject matter experts, and this bureaucracy corrupted this system. So at the end, they think about a new thing, the matrix. So with the matrix, there was a clear things like you have a streams, development stream, operational stream, and cloud stream. They even used more of an agile way, Scrum Kanban approaches. So there was a pure Scrum Master, there was a pure lead, there was engineers who focused on the development, who were focusing the operational, for example, who was responsible for on-calls, active monitoring, and there was a cloud team who was responsible for cloud migration and cloud toolset. But again, the challenge comes here. Communication confusion, because imagine if there is not Scrum Master, there is a lead, and some of them are changing each other. They didn't work eventually. Rotation period confusion, for example. I spent 1 week in the dev stream. I want to go to a cloud stream. Well, there should be an agreement. You cannot say that you just want to. Imagine 4 people working in the dev stream, they need to simultaneously switch with each other. It's not like I just want to and switch with me one guy. They didn't work. So finally, they found a balance. So they tried 3 structures that didn't work. But they also realized that everything was working, but they wasn't capable to use in the right way. So, and then they took a flat as a default, normal, daily basis structure. When it comes to make a decision, there was one person who was kind of expert in subject, most with the experience, and they start to ask. But we talk about in more of a flat way. So when it comes to a decision, one of the guys are just leveling up to make a decision. And to keeping a balance, they also start to use a matrix way. So it wasn't just like picking up one structure. It was a hybrid form of structure, and it was a clear balance of the rotation models. So everyone was simultaneously moving to one stream to a second stream. Finally, the result. How it's working. this is a calibration map. How at the end it looks today. So, as you can see, business involved in every aspect, both in development, both in operation, both in SRE. Processes onboarded, like incident management, root cause analysis, integration and feedbacks. This kind of a processes was involved and was advocated. As you can see here, there was an active deployment. They was actively deploying and was actively monitoring their root cause, and they're creating a task eventually after every failure or every success deployment. So this is a collaboration model how they ended the bring up, and this is the result at the end. So we can see, starting from 2015, production didn't change from the beginning, if we can compare with the 2012. The stress test showed how they can manage the outages, and the maximum committed only after the stress tests. Present today, the product is end of a development cycle, but it's actively supporting, actively using. So this is how the company eventually implement SRE. Thank you. Have any questions?
So in the beginning of this talk, you mentioned that quality is a completely different topic. So, excuse me for asking this, but is there any reliability without quality, or
Could be, yes.
how do you see it?
Let's say, giving a short example. For example, the PC. It looks very quality, it's very shiny, but if inside it's not working, it's always freezing, does it mean sets are related to each other?
But it's the other way around. I'm asking about reliability without quality.
Well, reliability without quality, you can still using your PC.
I mean, it can be ugly, but if the software is probably not working, that it's not really reliable.
Well, if it's ugly but software works perfectly, then the beauteous one, what you'll pick up? I think it's a completely different thing, quality and reliability. They can work together. Let's say, there was a good example with Vista. After XP, you see the Vista, there was a boom effect, right? There was this widgets on the desktop, there was a glassy window things. But it was really, if you are looking if you are not engineer, you're just looking, it's very quality product, you can say. But after you starting to using it, you can say it's unreliable. You forget about the quality, you will start to think about the reliability. Let's say about, for example, you have a car. Would you spend half of month of this car being in the service, or you just need to drive it?
Well, it's just when your car is reliable, you kind of assume that it's made of good quality.
Well,
But,
many cars are very ugly, but they are very reliable.
it might look ugly, but the quality of
But
production-
if you want, I think I need to highlight one thing. If you want both of them, you need to pay a lot. You need to really pay a lot.
That's true. I'm just wondering if one extends the other,
It-
or they just live in the different worlds.
I
because,
think-
I don't see them completely separate.
I think if you want to, if they want to live together, it's a matter of amount of financial. How much you're ready to spend. If you are talking about regular things, we will rather think about more quality or the reliability.
I believe in the outsourced companies there are a lot of software which we don't want to open, but it's working for the business, and if you have SRE engineers, it's reliable. But you definitely don't want to support it. But it give you the money. So that's why it could be different.
That's a good example.
I guess that's it. No more questions.
So I
Thank
didn't
you.
ask you. I didn't ask you.